Okay. Hello everyone. This is your first class through online. Okay. So before that we have been discussed many things in our offline classes, and today we are going to discuss about hypergeometric distribution. Before that we have been in detail discussed about geometric distribution, negative binomial distribution, and Poisson's distribution, and uh, and your the so-called your binomial distribution and corresponding moments we have been evaluated, and with the help of the moment we have been evaluated the corresponding mean and variance. So I hope that you have been well in your home and preparing for your coming exam. So let's start our today's lecture. Okay. So today we are going to discuss about hypergeometric distribution. So first of all, where the hypergeometric distribution is going to be used? Here it has been written, and that when the population is finite and sampling is done without replacement, so that the events are independent. Sorry, events are dependent, although random. Maybe these events will be random, but the events will be dependent with each other. At that time we are going to use geometric distribution. With an example here, we can consider an horn or bag with n capital N balls, m capital M of which are white and n minus m are red. Suppose that we draw a sample of n balls at random without replacement. You have to focus upon this. Without replacement from the horn, then probability of getting x white balls of horn where x less than n is mcx into n minus m c n minus x whole divided by n c n. So here, before we have to write this one, I am going to give a simple example that what is exactly without replacement and dependent. If we are going to be considered without replacement, then how the events are dependent to finding the probability. Here I have a simple example. You can go through this. Okay. So suppose we have the 1,000 balls. How many balls? 1,000 balls. Okay. Among the 1,000 balls, 700 red and 300 white balls. Okay. Now, if I will draw a ball, then probability of red will be 7 by 100. That means 0.7. And probability of white ball will be appear. That will be 0.3. That will be 300 by 1,000. 0.3. That means here you can see that if suppose this is a bag contains 1,000 balls, I drawn one ball, then the probability of happens red, it will be 700 by 1,000, that will be 0.7. And I replaced it again inside this bag, again I drawn. What will the probability of white? That will be 300 by 1,000, that will be 0.3. If I am not going to replace this ball once again inside this bag, then what will the probability of white? The probability of white will be 300 by 999, right? Okay. So if I will replace this ball inside this bag, then the probability of white will be 300 by 900. Again, suppose I not replaced this ball, then the probability of white will be 300 by 999. Again, if I will draw another ball, then what will the probability of red? Probability of red will be already one ball, two balls has been drawn. See, first ball has been drawn and the second ball has been drawn. Two balls has been drawn. The third ball, if I want to draw, then what will the probability of red? That will be maybe 700 by already two balls are already drawn. That means 998. That means here if I am not replacing the ball once again inside the bag, the probability changes each and every time. So if I am going to replace, see, if I am going to replace this ball inside the bag, the probability of the drawing the corresponding color ball will be same. See, if I will draw the first ball and it is red, the probability is 0.7. I replaced this one and drawn what will the probability of white, 0.3. Okay, so if I will replace each and every time, then the probability of red will be same, 0.7. Probability of white will be 0.3, right? That means it is looks like probability of head. If I will toss a coin, the probability of head, that is your head, 0.5. Probability of tail, that is your 0.5. That means fix. Okay, or we can say that this 0.7 is belongs to probability of success, and probability of failure, that is your q, that we can say probability of unsuccess or q will be nothing but 0.3, which is always constant here. In this case, here I written p. Okay, no problem. Probability of unsuccess will be 0.3, that is q. That means always it is constant if I am going to replace the ball after drawn. Okay, so this is your 0.7 probability of success or probability of getting red. Probability of unsuccess, that is your probability of getting white, will be 0.3. So here, if we are going to draw randomly 10 balls, randomly 10 balls I have to draw, what is the probability that, what is the probability x I consider, what is the probability that 3 red balls and 7 white balls? Here we are going to be use simply binomial distribution, that n is the number of samples for each drawn, in which x is your red balls. So ncx, p is so called success, p to the power x, and into q to the power n minus x. Using binomial distribution, we can found the corresponding probability that 10 balls has to be drawn. What is the probability that 3 red and 7 white balls? So this will be the answer. Okay, so if we are consider this example, that this will be 7. So this will be 10 10c3 and p to the power 3. This is 10. Okay, 10c3, p to the power 3, q to the power 7. Okay, q to the power 7, q to the power 7. Q is belongs to unsuccess or corresponding white ball. P is considered as success or corresponding red ball. So 0.7 to the power 3, here 0.3 to the power 7. What will the answer? That is our answer in this procedure, right? Now you consider one thing, that we are not replacing. In this example, we are not replacing. Then what will the probability? You think that we are drawing the 10 balls, but we are not replacing those things in the second drawn. First drawn we draw the 10 balls. So what is the ways what will the number of ways? 1000 C10, it will be in the denominator, and 3 will be red ball. So 700 are red balls. So 700 C3 into 300 C3. This is the probability that 10 ball is to be drawn, 3 red ball, 7 white ball. Okay, this is our first case. Second case, if we are not replacing the same 10 balls inside our or inside our bag, then again if I am going to do the same experiment, that I have to draw the 10 balls, then what will the probability of 3 red and 7 white balls? At that time it will be, see, total number will be already 1000 minus 10, how many? 990. So from the 990 I have been drawn 10 balls. Okay, so after the first drawing, 3 red ball already gone, 7 white ball already gone, I have been taken. So remaining red balls, how many? 697. So from 697 In our second case, from the 697, the red will be 3. And in our first drawn, 7 white ball already taken. So how many white ball remaining? That will be 293. So from the 293, we have to draw 7. So in the second draw, the probability of the same situation. This is the situation that what is the probability that 3 red ball and 7 white balls. This is this much. I not replaced. If I will do the same thing, 10 balls I am going to draw, then what will the probability? The probability will be 697C3 into 293C7 by 990C10. So here you consider without replacement what is the scenario. It is changes and each and every time. In the second time, it will be how many? In the denominator you can found 980C10. Okay. So here denominator will be changed and accordingly numerator also will be changed. So in this type of case, we have to use the so-called hypergeometric distribution. So in detail, we have to discuss about this distribution. We have to discuss its proof of PMF and moments of here hypergeometric HD. I simply write hypergeometric distribution. From the moments, we have to find out the mean and variance, and then we have to discuss approximation to binomial distribution. That means this hypergeometric distribution also will be approximate to binomial for some condition that also we are going to be discussed. So here what I am going to say that here if we are going to be consider here we consider 1000 is our total number of balls. So here if we are going to consider this 1000 equal to n, okay, capital N, m of which are white balls, are white balls. So here this is your 700, 700 is your white ball, suppose m, I considered m. Okay, so rest of the m of which are white balls. So this is your m. So rest of the balls are red, obviously. That means n minus m, right? And we have to draw a sample n balls. So in the example we have been considered the 10 balls has to be drawn. Okay, 10 balls has to be drawn. Okay, so here 10 is nothing but your corresponding small n. So small n is nothing but your 10. So here instead of 700, what we can write? 700 we can write, this is belongs to white ball. Okay, so instead of 700 we have to write m. So mc, this is the x, how many white ball we want to be intent to find out. So this will belongs to x into this 300 is nothing but total is your n minus m. So I can write n minus m. Here 300 will be n minus m. C into x will be nothing but how many we have been drawn? 10 minus 3 equal to 7. So this will be n minus x. So 10 minus 3 red balls, this will be 7. Okay, so here we drawn 10 balls minus 3 equal to 7. So here we drawn n balls, n minus x, the remaining one, whole divided by here how many? 1000 means total number n. C, how many we have been drawn? C, n. Okay, so in general without replacement case, if we want to find out the probability, of getting x white balls of n, when n balls are to be drawn, where n is the total number of balls, m is the are the white balls, obviously n minus m are the red balls. In this case the probability of finding the x white ball will be mcx into n minus mc n minus x whole divided by ncn. Okay, so this is so called your PMF. Also you can say that this is the PMF of your hypergeometric distribution. So here I can write simply HD represents hypergeometric distribution. Okay, so now this will be called as the PMF. So now here we have been written the definition: a discrete RV random variable X set to be follow the HD, that is your hypergeometric distribution, with parameter n, m, n. What is the n, m, n? Already we have been discussed. If it assume only non-negative values, these are the non-negative values, and its probability mass function, that is your PMF, is given by P capital X will be equal to X mcx, whatever written, the same thing I have been written over here, n minus mc n minus x by nc n, where x equal to 0, 1, 2 and 0 otherwise. So this is your PMF for hypergeometric distribution. How it will be the PMF we discussed with the example. Okay, so here n is the capital N is the positive integer, belongs to total number. M is the positive integer less than n. Okay, and n is the positive integer is at most n. So here n balls, n is sorry, at most n, yes, n is the total is the at most n. So here n is drawing, how many draw we are drawing from the total. So from the total we can draw less than n or total. Okay, from that how many the so-called number of white balls that we are going to be predict, or probabilistically we are going to predict, this is the so-called mass function in this situation. Okay, so if it is your PMF for the hypergeometric distribution, then it should have to be follow its properties. That means proof of PMF, that means if I will sum that 0 to x equal 0 to n, then it has to give the value 1. So we have to check that it is giving 1 or not. See, summation over x equal 0 to n mcx into n minus 1 cn minus x by ncn. So here ncn is not belongs to x, so I taken outside from the summation. X equal 0 to n mcx into n minus m cx. Let this is your equation number 1. But according to Vandermon's identity, see, this is a one theorem or identity. Here I not discussed in detail. The result of the Vandermon's identity here I discussed, and in some other video I will be provide this identity. Okay, so according to Vandermon's identity, it is known that summation over k to r, carefully you have to watch. Okay, k to r mcr into pcr minus k equal to, here just added the this upper powers, that is m, not powers, this is m plus p and k plus r minus k, that is your cr. So these two things will be add up, but the limit should be k. You just mark over here, k should be 0 and maximum will be r. Okay, so if it is so, then this summation will be m plus p cr. Let this is your equation number 2. Now here for this equation number 1, I have been considered that k equal to x. Okay, so here k I have been considered x, r I have been considered n. Okay, m, small m, this is small m, I have been considered m. P, this is p, I considered n minus m. So if I will be considered the symbols, I just interchange the symbols of the equation number 1. The equation number 1 will be, or the sorry, equation number 2, if I will be change the symbols only of the equation number 2, the equation number 2 will be this much, which is exactly equal to your equation number 1. So not equation number 1, this part of this value of the equation number 1, this is nothing but how much, summation over 0 to n mcx into n minus n minus x. So this value fully matched with this value, right? Here I just changed the symbols. Okay, we found the equation number 2 will be this much. So if it is this much, then the value according to Vandermon's identity, it will be, the power will be this power, this upper numbers, upper powers, or you can say power of c and superscript of c. You just consider that it is not exactly superscript because it is in combination format. So here these two is going to be add up, m plus n minus m and x plus n minus x, so it will be ncn. So this value is nothing but ncn. Now the equation number 1, if we are going to consider this value, this value, that means this value will be ncn. If I will substitute, then the ncn summation over this one is ncn by ncn, which will be equal to 1. So it has been easily proved. So hence this is your pmf of your hypergeometric distribution. Now we have to go for the moments of hypergeometric distribution. Here the moments is nothing but belongs to about the origin. Okay, we have been considered the about the origin. So we know that the first moment will be represented as mu1 dash, that is your ex, or the expectation, simply the expectation, and summation over 0 to n x into pmf, and here x equal 0 to n x into pmf, whatever we have been written here, I have been written simply same thing. And here I am going to suggest one thing, that this Vandermon's identity, if you know better previously, if you don't know, then just remember this one, and this identity proof I will give you in some other video. Okay, so this is x. Now this is mcx can be written as, carefully you have to watch. Okay, mcx can be written as m into m minus 1 factorial and divided by m minus x and x factorial. X factorial is nothing but x into x minus 1 factorial into the same thing it has been written, nothing changed. And here ncn I written. Okay, so here x got cancelled, so m into m minus 1 factorial, m into m minus 1 factorial, x into x minus 1 factorial, x into x minus 1 factorial, m minus x factorial into n minus mcn minus x whole divided by this one. This one ncn can be written as n factorial by small n factorial into n minus small n factorial. Okay, so now here you can see that I have been taken outside this m value, and here you can see this n factorial can be written as how much, n into n minus 1 factorial, right? Okay, so and this n small n factorial can be written as n into n minus 1 factorial. Okay, that n by n I have been taken outside from the summation, so rest of the things can be written as, so here you can see rest of the things whatever we have, by taking m outside, here numerator taken out m outside, and denominator, from the denominator we have been taken n by n taken outside, rest of the things m minus 1 factorial by x minus 1 factorial into m minus x. See, this much only, this much can be written as m minus 1 cx minus 1, no problem. So and this one n minus m cn minus x. Okay, and then here from n from this one, if I will be taken outside n by n, the rest of the things whatever we have, that means it will be after taking this one outside, this will be this much into n minus small n factorial. Okay, n minus 1 factorial by n small n minus 1 factorial into n minus small n factorial, n minus small n factorial. So this much value can be written as n capital N minus 1 c small n minus 1, simply, no problem. So here you just this n gone to numerator, n m by n summation over yes, if this values m taken outside, n by n taken outside, so limit obviously it will be x equal to 1 to n. So x equal 1 to 1 this 1 to n this much. So here x equal 1 to n and this much, same thing I have been written. Okay, up to this much we have been completed. Here we have been going to be change somewhat uh, to apply our here Vandermon's identity. To apply the Vandermon's identity, here I am going to change somewhat the notations whatever we have in this summation, inside this summation. Okay, how it is, let's see. Here now Here I am going to change the notations only. See, here I considered x minus a equal to t, m minus 1 equal to a, and small m equal to n minus 1. This step is most important. Carefully you have to watch. Okay. So here if I am going to consider x equal to 1, then t will be equal to 0. So t equal to 0. If I am consider x equal to n, then t will be equal to n minus 1. So limit changes from t equal to 0 to n minus 1. Here m minus 1 is going to be changes as a. So a c x minus 1 we have been considered as t. So a c t, right? Here you can see m minus 1 equal to a. So m equal to a plus 1. So here n minus m, that means minus a minus 1, minus a minus 1, c n minus x. So here instead of x, if we are going to be put t minus 1, sorry, t plus 1, here x equal to t plus 1. So here I am going to put t plus 1, it will be n minus t minus 1, n minus t minus 1, and in our denominator n minus 1 c n small n minus 1, whatever we have been taken as m. Okay. Now here n minus 1 we have been considered as m. So here t equal to 0 to n minus 1 or t equal to 0 to m, because n minus 1 is considered as m. So m act into, here n minus a minus 1 can be written as n minus 1 minus a c. Here n minus 1, n minus 1 is there, so n minus 1 can be written as m. So m minus t divided by n minus 1 cm, right? Okay. Now by using Van der Waals identity, what we know, that if k equal to 0 to r, m c k is there into p c r minus k, then this will be 2 will be going to be add, and this is going to be add. Okay. So here if I am going to compare this and this, exactly same manner it is. You can see t equal to 0 to m as k equal to 0 to r, right? So here act, so here act is there. You just concentrate upon this one, not denominator, this one, act as like m c k. So here p c r minus k means this minus this. Okay. And this p is nothing but any arbitrary number. So here n minus a is there. So if I am going to match this and this is very similar. So what will be value of this one if it will be used by Van der Waals identity? So it will be, this summation will be this power, or this, you can say that not actually it is not the power, but this a and n minus 1 minus a is going to be add up. So it will be a plus n minus 1 minus a, and this 2 is going to be added with each other, that will be t plus m minus t, that is nothing but m. So here a plus n minus 1 minus a got cancelled, we found n minus 1 cm. So numerator we found n minus 1 cm, denominator already it was there, n minus 1 cm. So both are equal, got cancelled. So we found that this much only. So here we found mu1 dash, or first moment about the origin, or expectation value about the origin, will be equal to n m by n. Okay. Now we have to move for the second moment, right? We know that the second moment is nothing but mu2 dash, that is your ex square. See in which way we have been derived this one. Similar manner we are going to be derive these things. Okay, see, this is x square. So expectation of x square will be x equal 0 to n x square into PMF. PMF we know that this one. So here x square has been rewritten as x into x minus 1 into x. So here x square minus x plus x, so x square, no problem. So this is written as such, no problem. Okay, now I am going to multiply this with this with this one. Okay, so here x into x minus 1 into this much, x into x minus 1 into this much, plus summation over x equal to 0 to n is there, x into this much, x into this much. This value already we have been evaluated as your expectation value or first moment, that is your n m by n, already we have been evaluated. So now we are going to evaluate this one. Carefully you have to watch here. Here x into x minus 1 is there. This one mcx can be written as m into m minus 1 into m minus 2 factorial divided by see mcx is nothing but m factorial divided by x factorial into m minus x factorial. Okay, so m factorial here can be segregated as m into m minus 1 into m minus 2 factorial divided by x factorial can be rewritten as x into x minus 1 into x minus 2 factorial, and m minus x factorial is there. So whole divided by ncn can be written as n into n minus 1 into n minus 2 factorial divided by this is n factorial. Small n factorial can be written as n into n minus 1 into n minus 2 factorial into n minus n factorial, and here this term is there, this term is written as such, plus nm by nm by m. This is small n capital M by capital N, right. Now here you can see that this x into x plus 1 got cancelled. Now I am going to take outside m into m minus 1 from this term, and here n into n minus 1 divided by n into n minus 1, capital N into n minus 1, small n into n minus 1, and here m into n minus 1 I taken outside from the summation, because there is no role inside the summation. So here m into m minus 1 whole divided by n into n minus 1 divided by small n into small n minus 1. So as here m minus 1 n minus 1 term I have been taken, so obviously the summation will starts from x equal to 0 2 to n, so it will be 2 to n. Rest of the things here you can see this much will be written as m minus 2 c x minus 2, and this term is there as such I have been written, and here you can see this much will be written as n minus 2 c n minus 2. Okay, so and here it was there as such it has been written. Okay, now here I am going to be change the notations. Carefully you have to watch. Similar manner how we have been done here, same manner I am going to be do this one. See, t equal to x minus 2, consider that t equal to x minus 2, m minus 2 as considered as a, and m small m considered as n minus 2. So here x equal to 2, then t will be equal to 0. If x equal to n, so t will be n minus 2. So summation changes from x equal to 2 to n, t to n minus 2, and here m minus 2 is nothing but a we have been considered, and c t I have been considered that x minus 2, and here n minus m, here m is nothing but a plus 2. So n minus m means n minus a minus 2, and c n minus x. So here x is nothing but t plus 2. So if I will put it over here, this will be n minus t minus 2 whole divided by n minus 2 c n minus 2 n m by n, right. So here summation over t is equal to 0 to m, because n minus 2 is nothing but your m, and act here I can write n minus 2 minus a, and c n minus 2 can be written as small m minus t. Okay, so here this much summation again I am going to be considered. So for this summation again I am going to consider the van der Waals identity. Here you can see that means this plus this plus this, it will be add, and this is going to be add. Here you can see a plus n minus 2 minus a, that means n minus 2 c m. Here n minus 2 c n minus 2 is nothing but itself m, so both are cancelled with each other. and we are going to get the value is 1. You got my point? See here, this value is your how much? This is value is ACT is there. ACT will be there. ACT will be there. Okay, this is ACT. ACT. Okay, into this will be this will be, so sorry, this will be add up. That means in the numerator it will be n minus 2. So n minus 2 c, this will be m whole divided by c. Here n minus 2, n minus 2 c, n minus 2, small n minus 2 already we have been considered as m, so both are cancelled, it will be 1. So we found that here at last this much value, m capital M into capital M minus 1, small n into small n minus 1 whole divided by capital N into capital N minus 1 plus small n capital M by capital N, because this is 1. So we found that the second moment, that is a mu21 or ex square, mu21 ex square, it will be this much. So this is nothing but the second moment. So now we are going to go for the variance. Already expectation value we determined, right? This is nothing but your expectation value, that is your nm by m n n. And now we are going to go for the variance. So here Vx variance equal to, we know that ex square minus ex whole square. Ex square we found just now. Here this much value I have been substituted over here. This much value minus nm by n whole square. So here just a simplification, only simplification is there, and finally we got this one. So simplification also I am going to be, so you see what I done, that I just added the 3. And we got this one. See here n square n minus 1 by LCM. So here I am going to be multiply that n, capital N is multiplied with this one, and with this one it is multiplied by n into n minus 1 obviously. So here n square m square will be multiplied by n minus 1. Okay, because it is n square is there. So here you can see that here n square m square n plus n square m square. So from these terms we have been taken common that n small n and capital N, small n capital N. This is capital N, small n and small m whole into, this will be m into m minus 1, n into n minus 1 plus already this taken outside, so n minus 1. So this is there divided by n square minus n square into n minus 1. So here n m into, again I multiplied these things, so we got mn minus m minus n plus 1 plus capital N minus 1. So 1 got cancelled here. So minus n square m square n plus n square m square whole divided by n square n minus 1. So Vx will be equal to, here you can see, if I will multiply this with all the terms, we can get this one. Carefully you have to watch, and carefully you have to write down your notes. So n capital M square small n square minus capital N small n capital M square minus capital N small n square capital M plus capital N square small n capital M minus n square m square n square m square. So this and this both are same, got cancelled. Now we are going to consider this and this, this and this. Then I have been taken outside n m, so this will n minus 1 n minus n, and considering this term and this term, if I will be taken outside m square n, it will be small n minus capital N whole divided by this one. So here n m n minus 1, so taken outside, no, if I will take common minus, then it will be capital N minus small n divided by n square into n minus 1. So it will be n minus n, this minus this n m minus m square n, this one whole divided by n square into n minus 1. So Vx, we found that small n m, okay, n minus 1 into n minus 1. Okay, here so see, from these two terms, if I am going to take n, small n and m outside, this will be n minus m into n, capital N minus small n divided by capital N square into n minus 1. So this is your so-called variance of the HD, hypergeometric distribution. Now we are going to go for the approximation to binomial distribution. See, this hypergeometric distribution tends to binomial distribution for some condition. At some condition it will be approached to the binomial condition, where when n, capital N will be tends to infinite, that means the number of samples will be infinite and m by n will be considered as p. Okay, at that time the PMF of HD will be converted to PMF of BD. Okay, binomial distribution. So here we, how it will be, you just watch it. This will be PMF of HD will be this much, that we know, MCX into n minus MC n minus x by NCN. So here this can be written as m factorial by m minus x factorial into x factorial, and this can be written as n minus m factorial whole divided by n minus m minus n plus x factorial, and n minus x factorial whole divided by this one, n factorial by n minus n factorial into n factorial, right? Carefully here you have to watch. So, so here m factorial can be written as m into m minus 1, m minus 2 up to m minus x plus 1 into m minus x factorial. See, this is the term. Next term is the m minus x. Next term m minus x minus 1 and so on. So here I written m minus x factorial whole divided by m minus x factorial into x factorial, and this n minus m factorial can be written as n minus m minus 1 and so on. This will be the n minus m minus n plus x plus 1, and the next one will be n minus m minus n plus x factorial. Okay, because see, n minus m minus n plus x, here n minus m minus n plus x, but it is 1 plus 1, that means next term will be minus of this one, and then minus 1, then minus 1. So here I stopped that this much factorial divided by this one, as such I written this one, n minus x factorial, as such I written. Okay, into here, see, this one I taken numerator and this one I taken considered as denominator. See, so this one n minus n factorial into small n factorial. Okay, this one gone to up, and this one will be the denominator, obviously n factorial. Okay, yeah, this will be n minus n factorial into n factorial divided by capital N factorial. So this will be n minus n factorial into small n factorial. Small n factorial divided by n factorial can be written as n into n minus 1, n minus 2, and so on, n minus n plus 1, and the next term will be n minus n, then n minus n minus 1, n minus n minus 2, and so on. So here I stopped that as writing n minus n factorial. Okay, okay. Then here you can see that m minus x factorial got cancelled. Okay, so here you can see n minus m minus n plus x factorial, this and this got cancelled, this got cancelled, and here n minus n factorial got cancelled. Remaining terms here I am written that m into m minus 1, m minus 2 up to m minus x plus 1 by x factorial. Here n minus m minus 1 up to n minus m minus n plus x plus 1 whole divided by n minus x factorial. Okay, then n minus x factorial into is this one, n factorial, and this much, n into n minus 1, n minus 2, n minus n plus 1. Okay, now what I done, that I have been divided capital N in each of the term. Then what I got, see, so before that I have been taken this side outside, that means separately I have been written. See, n factorial I written, then x factorial is there, n minus x factorial I have been taken separately, then other terms divided with capital N. Say here m is there, m minus n, here m is there, m minus n minus 1 by n, here m minus n 2 by n, so on, m by n. Here I taken minus common, so it will be x minus 1 by n. Here x minus x plus 1, so I taken common minus, so it will be obviously x minus 1 by n. Likewise here I divided n with each term. This will be 1 minus m by n, 1 minus, if I will take 1 minus m by n minus 1 by n minus m by n minus 1 by n and so on. This will be 1. This m by n, here I taken minus outside, this will be n minus x minus 1, n minus x minus 1 divided by n, and divided by this, these terms are there, these are the terms. So these are the terms means by divided by n will be 1, this will be 1, 1 by n, here 1 minus 2 by n and so on. It will be n by n will be 1, and taken outside minus, it will be n minus 1, n minus 1 by n. Now we are going to consider n tends to infinity, then the total samples we have been considered as infinite, and n m by n and as p we have to just put over here. See, if I will consider n tends to infinity, this 1 by n, 2 by n, x minus 1 by n, these are going to be 0, and m by n wherever we have that we are going to put as p. Okay, now next page I done the same. So we got that, see, this value n factorial by x factorial into n minus x factorial can be written as ncx. Okay, so here ncx, and here you can see this is important. See, this will be p. Okay, this will be p into p, this value is 0. If I will consider n tends to infinity, this is 0, this 2 by n is 0, x minus 1 by n will be 0, and p, this will be p into p into p, up to how many p we can get. See, if this is x minus 1 term, before that it will be x term. Have you got my point? See, if this is x minus 1 term, then before that this term will be nothing but is your, so up to this much, how many terms? X terms. So we can so we got p into p into p into p, how many times? X times. So easily we can write x times again. Then it is 1 minus p, because 1 by n will be 0, up to how many times? Up to n minus x times. Okay, up to here 1 minus p, 1 minus p, 1 minus p, up to how many times? Up to n minus x times. Okay, so same thing it has been written, 1 minus p, 1 minus p, up to n minus x times, then divided by 1, because 1 by n tends to infinity 0, this will be 0, this will be 0, and 1 1 1 will be there, it will be 1, denominator will be 1, and finally we got ncx into p into p into p up to x time into 1 minus p, 1 minus p, 1 minus p, up to n minus x time. So we can write ncx into p to the x into 1 minus x to the n minus x, right? So we know that p minus 1 is nothing but q, that is your binomial distribution PMF. So here we found that by conditions of n tends to infinity, m by n will be p. If it is so, then the HD hypergeometric distribution approaches to the binomial distribution. Some other way also we can easily find out this relation between HD and BD, that we know that mean of HD is nothing but nm by n, and variance of HD is equal to Bx equal to this much, and we have to consider n tends to infinity, m by n for Ex and Bx we get. See, Ex how much? N into m by n, you just put as P. So this is nothing but mean of the binomial distribution, right? So variance is nothing but this one, you just divide n. Okay, so here you can n into m into here 1 minus m by n, 1 minus m by n into 1 minus n by n. So this, see, n square I have been divided with this term, so it will be 1 minus m by n, 1 minus n by n. Just put n tends to infinity means this will be 0, this will be 0, and we got nm into, sorry, this one is your m by n means p, but n by n will be, n tends to infinite means it will be 0. So we found nm into 1 minus p, nm into 1 minus p into 1 divided by n minus 1, right? So 1 minus p is nothing but q, right? So again, if I am going to take n common, so it will be 1 minus 1 by n, 1 minus 1 by n, here n tends to infinity, it will be 0. So we found n capital M q by n. Okay, so m by n again p, so npq, which is nothing but the variance of bd, binomial distribution. So in this way also we can prove that if n tends to infinite and m by n will be p, then it will be the bd, sorry, hd, hypergeometric will be converted to bd. So this is all about your binomial distributions, whatever you have in your syllabus. And your next class we are going to discuss multinomial distribution, multinomial distribution. Okay, so carefully you have to watch this video and write down your note and prepare for your next class. So thank you so much for watching this video. Thank you.